Hi everyone and welcome to my YouTube channel. So far in this functional equation course, we've discussed two methods, the substitution strategy and surjective functions. And now we'll be learning a new method, and that is injective functions. This method is used quite often in lots of Math Olympiad functional equations, so we'll be learning injective functions. But first, let's talk about injectivity in general. When do we call a function injective? So we call a function f is injective. What does that mean? Well, that means for any two real numbers, or any two numbers that are in the domain of the function, so for any numbers a and b satisfying f of a equals f of b, we have a equals b. So if we have two numbers a and b that satisfy f of a equals f of b, then we have a equals b. So that is injectivity. We call f injective when f of a equals f of b means that a equals b. Of course, if a equals b, then f of a equals f of b, because f of a equals f of a. So in fact, we have this, not just f of a equals f of b implies a equals b, but also a equals b implies f of a equals f of b. Okay, so that is injectivity in general. And now we'll be discussing a practical problem in which we'll be seeing how we can use injectivity to solve functional equations. So what are we waiting for? Let's get started. So our problem is from the Saudi Arabia Balkan Math Olympiad Team Selection Test 2013. And in this problem, we're asked to find all functions f from R to R such that f of x plus y equals x plus y plus f of y. Okay, so the first thing we do when we look at this functional equation, we realize that x is free quantity and y is free quantity, and that reminds us of surjectivity. We said earlier in the previous videos that when we have free quantities, then probably we can prove that f is surjective. So can we prove it actually? Look, here we have f of y and here we have f of something. So simply we can substitute y with 0. If we substitute y with 0, we're going to have f of something equals, this is f of 0, constant, and this is 0, equals x plus f of 0. So f of something equals a surjective quantity, which means that indeed f is surjective. So actually we can say that f is surjective. Okay, that's good. But what about injectivity? How do we prove that a function is injective? Well, in general, the classical way is the following. You want to have one quantity, one variable, for example, y or x. Let's say that it's x. Okay, so you want to have some free quantity, x, on one side. Okay, so here we have x. Let's write that down. And we want to have each other x, we have one free x, and each other x is inside f. So, for example, here we have f of x. Here we have f of x. But we can't have f of x plus something, for example, y. We want each x to be inside f. So we need to have only one free x and other f of x in the functional equation. If we have these conditions, then we can prove that f is injective. Okay, so let's see if we can make this in our functional equation. Here we have x is free and y is free. Let's look at y. Here we have indeed one free y and one y inside f, so that's good. But look at here. Here we have f of x plus y. So we can't use y to prove injectivity. But look at x. We have one free x, and we have only one other x, and that is indeed inside f. So we have f of x here, and we have x here. So we should be able to prove injectivity. But how can we exactly prove that f is injective? Okay, so how do we prove that f is injective? So let's assume by contradiction, let's assume that we have two numbers a and b. So to prove f is injective using x, let's assume that we have a and b such that f of a equals f of b. And we want to prove that a equals b. So how can we use x in order to prove that f is injective? Well, that's very simple. We will substitute x with a, and then we'll substitute x with b, and subtract the two relations to get a equals b. Well, why is that true? Because if we substitute x with a and y as y, we are going to have the left-hand side here contains f of a. But when we are going to substitute x with b, we're also going to get the left-hand side is the same, because here we have f of a equals f of b. So the left-hand side is indeed the same. So we are subtracting them. This left-hand side will be 0. But what about here? Y is going to be cancelled. So here we're simply going to have a minus b. So we're going to have a minus b equals 0. So we can simply say that by subtracting p a y minus p by, we're going to get a minus b equals 0, which means that a equals b, which means that f is injective. So we have that f is indeed injective. So that's why we said we can prove our function f is injective when we have only one free x and all other x are inside f. Because when we substitute x with a and then substitute x with b, when we subtract these, all f of x will be cancelled because f of a equals f of b. And we're going to have 1a minus 1b equals 0. So we're going to get f is injective. Now I hope that makes sense. Okay, so now let's subtract this. Let's erase this. Actually, there is one term that we use when our function f is surjective and injective. We call our function bijective. So if you see in some solutions f is bijective, then that means f is surjective and f is injective. So let's simply write our function f is bijective. That means it's both surjective and injective. Okay, what about now? How can we use this injectivity in order to solve our functional equation? Well, let's discuss the meaning of injectivity again. From the definition, we've seen that if we have a and b such that f of a is equal to f of b, then that means a equals b. Doesn't that mean something simpler? Well, imagine here we have f of something equals f of other thing. Then we simply can cancel these f's, right? So it's just like dividing by some number. We can simply cancel f with the other f. So if we have f of something equals f of something else, then we can simply say something equals something else. So that's the idea of injectivity. So I think you can guess how we're going to use injectivity now in order to solve the problem. You can see that in the left hand side we have one f, and on the right hand side we have one f. So f of something and f of something else. So can we make these equal? Well, that's simple. We're just going to make x plus y equals 0. How can we do this? By simply substituting y with minus x. So let's do this now. So we are going to substitute y with minus x. So p x minus x. We're going to get one big F, and one small f, minus x here, and here minus x, and that is equal to f of minus x. But guess what? Our function f is injective, so we can simply cancel this f with this f, which means that we have simply f of x minus x equals minus x. So we also can cancel these two, which means that now we have f of x minus x equals 0. Now look at this simple functional equation. We just have f of x minus x equals 0. And also we have f is bijective. So how can we find our function f from these two information? F of x minus x equals 0 and f is bijective. Well, if we have here f and here another f, then we can use injectivity to cancel these f with each other. But here we have 0. So can we actually create some f from this 0? Well, yes, we can. How? By simply using the fact that f is surjective. Since f is surjective, then we must have, some value alpha such that f of alpha equals 0. Because our function f is surjective. And in fact, this alpha is constant. So it's only one alpha. We can only have one alpha, for example 2 or 3, because f is injective. So we can use this alpha to make this 0 f of alpha. You see this trick? Now we can cancel these f's together, and now we simply, ladies and gentlemen, have f of x equals x plus alpha. See this magic? We had this functional equation, but using surjectivity we have f of alpha, and using injectivity we cancel these f together to get f of x minus x equals alpha, which means that f of x equals x plus alpha. And simply we have our function. We just need to substitute here in order to find the value of alpha. So let's substitute it. Of course, we're going to have x plus 2 times y, and here x plus 2 times y. And let's count the numbers of f. Here we're going to have 1 alpha, 2 alpha, 3 alpha, and here 1 alpha, which means that 2 times alpha equals 0, which means that alpha equals 0. So our function f is simply the identity function. So f of x equals x. And now we are done. So the moral of the story here is that surjectivity is useful, injectivity is also useful, but combining these together we get bijectivity, which is too powerful technique that it alone can solve lots of functional equations in Math Olympiad contests. So in the next videos we'll be solving some problems that need surjectivity, injectivity, or sometimes bijectivity, and we'll be starting to look at more advanced problems from the IMO, not just problem 1 and 4, but even problem 2 and 5. So I hope you guys like this video. Like and share and subscribe to the channel, and see you guys in the next video.